Okay, good evening, ladies and gentlemen. We are live again. Today, we are going to do another trig and pre-calc section, and this live stream is brought to you by Chegg. Over there, we have our QR code. Go ahead and scan it so you can check out more of what Chegg can offer you. And I do have a question because last time, right, somebody requested law of sine question. So this is the question that we are going to look at today, right? First, and then if you have questions later on, feel free to drop them in the chat. I'll be happy to answer them for you. But let's just cut to the chase. Let me tell you that here's the question. Given that we have a triangle ABC and we know all three sides, little a is 3, little b is 3.9, and little c is 5.8. And I'm also going to tell you an angle. Measure of angle A is equal to 28.25 degrees. My question for you guys is that, what's the measure of angle C, right? So go ahead and think about this right here first, depending on how you want to do it, and leave your answer in the chat. I can see it, all right? So just leave an answer in the chat. So let's see who got this right. And just a small challenge though. Try to use law of sine, right? Try to use law of sine, law of sines. But technically you don't have to but I'm not going to tell you. Just go ahead and think about it. Right? So welcome everybody. I see a lot of people coming in already. Thank you guys so much for coming. Welcome back if you have been here before. But if you're not, then welcome. This is the online office hour hosted by Chegg. And then scan the QR code so you can check out more of the information. If you are taking calculus or any other classes such as general chemistry or even computer science, you can also check that out. We do offer live streams throughout the week to help you with your studies. Okay, so let's see who has the answer for this right here. I know we're not. Let's just ignore this for now. Let me just ignore this for now. Why not use law of cosine? I know this is the point I want to make, right? So the question is, try to use law of sines. I'm going to erase this so that you guys don't use law of cosine unless you have been here already, write down the little c value already, then fine, you can use it. But try to use law of sines. All right, welcome everybody. And today's goal is I'm going to go over this question, and then later on, if you have any questions, if you're taking pre-calc or trig right now, you can drop the comments in the chat and let me know. And I'll try my best to answer them for you. All right, I have seen one correct answer already. And I'm actually going to discuss why this question is like a tricky one. And again, this is just from last week. So I think you guys have enough time. Let's go ahead and solve this. For this kind of questions, I would recommend you guys to, well, actually, let's just kind of work it out to see what it is, okay? So if you use law of sines, of course, we have capital A and little a, and I want to figure out, oh, I have to tell you C. I cannot tell you, let me see. I have to put down the C, okay? I have to put down the C, 5.8. I have to put down the C. I told you guys this earlier already, but anyways. So A and A, C and C. So we can use law of sines. Here we go. If you set it like this, I'm going to do like this. Sine capital C over little c is equal to sine capital A over little a. And then just throwing the numbers. C, we don't know yet. Little c, we know is 5.8. So sine C over 5.8 equals sine A is 28.25. So sine of 28.25 degrees over little a is 3. Now check this out. I'm going to multiply this to both sides and then take the inverse to both sides. So you can see that C, and this is the measure for angle C, equals the inverse sine of 5.8 times this. And then we have sine of 28.25 degrees over 3. Okay. Now, go ahead and use your calculator to try. Actually, I think it's being blocked. I'm sorry. I'm going to write it up here for you guys to see better. So right here, measure angle C is equal to inverse sine of 5.8 times sine of 28.25 degrees over 3. And if you use a calculator, right? If you use a graphing calculator, and make sure your calculator is in the degree mode, you will get approximately 66.2 degrees. But is this really the answer? All right, let me take a look. Hello, everybody. Thanks for coming. And just real quick, I saw a very interesting question. Is there a lot of tangent? Yes, but I'll tell you it's not so common. There is, but it's not so common. You really don't see that in pre-calc or whatnot. All right, so we do get like 66.2 degrees, but is this really an answer? Well, remember that I gave you little a, little b, and little c. Whenever we have all three sides, we can actually use the law of cosines. So I'm going to just use law of cosine for you guys as well. This is law of cosine. In this case, I'm going to do the following. Check this out. I will be able to tell you c is equal to what? C equals, and let me actually write it with this notation. Measure angle C equals, you take the inverse cosine of, ready? So to get C, you have to do this square plus that square. So I will just do, okay, I will write down all the steps. A square plus B square minus 2C, okay, all over 2AB. Hold on, I think I remembered it wrong. What do you... No, minus C squared, and then I'll be teaching for the whole afternoon. Minus C squared, and then over 2AB. Okay, now better. All right, now check this out. If I throw in the numbers, little a, little b, and little c into here, and we will get, this is the inverse cosine of little a is 3, so 3 squared, plus little b is 3.9. Little c, which I told you right here, 5.8 squared over 2 times ab, which is 3 and 3.9. Okay, for this one right here, you get approximately, here I have to look at my value, 113.8 degrees. So what's going on? Which one is actually correct? All right, law of sines, I end up with 66.2. Law of cosine, I get 113.8. So which one is correct? All right, go ahead, drop a comment. Let me know if you go for law of sines or law of cosine. All right, just put down sines or cosine. Let's see. What do you guys think? I want to see the folding. So for the people just coming, check this out. We have this trig question, and we have law of sines versus law of cosine, and we end up with 66.2 versus 113.8. So which one's correct? Law of sines or law of cosines? Drop a comment in the chat and let me know. Yeah, this is the reason why I actually give you guys all three sets, and then sometimes when you have more information, you actually have to be careful. And I'll tell you one thing when you are debating between law of sines versus law of cosine. All right, I'm going to tell you guys what the answer is. Ready? Usually when I do the blue pen, it's like, that's the wrong answer. But no, in fact, this one here is correct. This is the correct one. This right here is the correct one. This right here is actually not done yet. Not done yet, right? So keep this in mind. I'm going to write this down right here. Measure angle C is approximately 113.8 degrees. And this is when we use law of cosine. And I'm going to erase this and I'm going to tell you guys why law of sines unfortunately did not give us the correct answer. Yet. The keyword is yet. Here's the deal. If you draw a picture real quick, then let's see. We have measure angle A is being 28.25 degrees. So I'm going to draw it like this. All right, I'm going to draw it like this. So this is my 28.25 degrees, something like this. Something like this. 28.25 degrees. And then I'm going to label, let's say this is my angle A. I'm going to say this is my C, which is 5.8, which is the longest in the triangle. And I'm going to say this is little B, which is 3.9. Right? So we have this right here so far. Right? And then B we don't know. I mean the side B we don't know, but based on this, right, we can draw a triangle like that. And then I'm just going to connect it like this, something like that. This right here will be angle C. And then this is angle B. Sorry, little a is right here. I meant this is side A. It's 3. So you have 3 and 3.9. In order to get 5.8, it has to be really open. This side, it's going to be more than 90 degrees because of this side. And this is going to be more than 90 degrees. Why? Because you can use the Pythagorean theorem. If you use the Pythagorean theorem to see that this is more than the square of this plus the square of that, if you square this. So this C right here has to be greater than 90 degrees. All right? Now, if you use law of sines, how exactly can we get the answer though? Here's the deal. You have to know the identity that. So I'll make a note. Note, when we have sine of the angle theta, this right here is equal to sine of 180 degrees minus the angle theta. So in fact, the first answer that we got from law of sines, unfortunately, is like the acute version of that. And also you have to know that, and another note, when you use inverse sine of something, this right here, it gives you the answer from 0 to, I'm going to use degrees. Okay, so this is going to be from 90 degrees to negative 90 degrees to 90 degrees. Okay? So what we will have to do is we will have to take this value and do 180 minus that. So in fact, the answer here will be 180 minus this answer right here, 66.2. So this right here actually gives you the answer that we have over there. So this is 113.8 degrees, which is the answer that we have right here as well. So again, the limitation for this right here is because when you use the inverse sine function, the output is only from negative 90 degrees to positive 90 degrees. So if you have an angle that's bigger than 90 degrees, you have to do another step, which you do 180 minus this answer, and then you see that. The best thing for you to do is to draw a picture and analyze that, and then I will tell you why this is more than 90 degrees real quick. Because if you do 5.8 square, if you compare this with 3 square plus 3.9 square, okay, then you'll see that this angle will have to be bigger than 90 degrees. So just kind of compare the squares of them. If they are equal, that means this answer is going to be 90 degrees. Okay? So that's the first question, warm up. And by the way, if you want to use law of cosine, the answer for that is always going to be in between of 0 and 180 degrees. Whenever possible, use law of cosine. Use law of cosine. That's the best. Okay, Welcome, everybody. Thank you guys so much for coming. If you have been here before, welcome back. If this is the first time, welcome. My name is blackpenredpen. This is the live office hour hosted by Chegg. And we will be here next Monday as well from 6:45 to 7:45 p.m. Pacific time. Right? And I think we're done with this. So right now, if you have any questions, you can go ahead and leave in the chat, and I will do my best to answer them for you. And go ahead and scan the QR code over there. You can take a screenshot of your phone and then just go to your photo, and then you can just click on it, and then you can, go to the link, or maybe check the link in the description so you can check out more of the live streams that we offer throughout the week. I will be back next Monday, but there are other instructors. They are also great. They will be doing calculus. They will be doing chemistry, computer science, all the good stuff. So just go ahead and check out the schedule over there. All right, right now, yes, it's 7 p.m. where I am. So let me pause for a little bit. Let me take a look at the question that you guys have. Yeah, I see some people mention subtracted from 180. That's the question that we did. Perfect. Be careful when you use law of sines. If it's an obtuse triangle, you will have to do the 180 minus the answer that you got from the inverse sine. Pre-calc is like half algebra, the harder version algebra compared to your algebra 2 class before, and then the other half is like trig. So yeah, this is how I tell my pre-calculus students. In fact, this semester I'm also teaching a pre-calculus class at my school. Okay, do you guys have any questions? Either trig related or pre-calculus related? And perhaps I'm going to give you guys another one. We also went over how to do the polar coordinate last time. So why don't we try to practice some polar coordinate equations, right? So let me do a polar equation, and I'm going to talk about how to solve trig equations in general. If you have a specific equation, feel free to put in the chat. I think that's easier for you to understand and then for me to provide the help. But right now, let's go ahead and talk about a conversion question. I'm going to convert let's talk about a line. Let's say we have y is equal to 3x minus 1. This is an equation of a line in the Cartesian or rectangular form. Two polar. So let's see how we can do that. Yeah. So firstly, from last time, we went over the conversion formulas. So make sure you go back to the live stream if you want to review that. I will write it down for you guys. If you want to go from rectangular to polar, you can always do this. Very straightforward. X is equal to r times cosine theta. X is cosine, and then y is the sine. Just like how you have it on the unit circle. All right? When you go from rectangular to polar, these two are the main ones. And then just plug them in. Have a look. Put this right here. We have r times sine theta equals 3. And then this is r cosine theta, and then minus 1. And technically, you're done. Because this is a polar equation. Move on. No, just kidding. Of course, usually what we want to do is we want to isolate the r. Because in the polar situation, we want to have r as a function of theta. So I'm going to write it down like this. R as a function of theta. As opposed to this right here, it's y as a function of x. Y of x. Okay? So right here, let's move this to the other side. We have r sine theta minus 3r cosine theta, and that's equal to negative 1. What can we do next? R and r here, we can factor out the r. Yeah, so factor this out. Factor out the r, and this is a multiplication. We have sine theta minus 3, r is out already, cosine theta, and that's equal to negative 1. Then divide this to both sides. R by itself equals -1 over that. Oh, sorry, you guys cannot see that. I'm going to write it down right here. So, okay, I'm going to write it down right here. R is equal to -1 over sine theta minus 3 cosine theta. Okay, so this right here is the polar equation. Can I solve the Riemann hypothesis? No, I wish I could, but I can't. I'm sorry. That's perhaps the most well-known question. That's perhaps the most well-known math question in the world. Well, most famous one, or maybe most famous and solved question, I should say that. Okay, so let me see the questions that you guys have. Okay, let me see. 1, 2, 3, 4, 6. If you want me to solve a trig equation, just give me like a specific one. That would be easier for me to help you. Okay, cool. All right. All right, let's talk about how we can solve that equation. I totally understand that solving trig equation is very different than compared to solve like a quadratic equation or like a rational equation. I will tell you guys what we actually have to pay attention in order to solve that. So the equation is, hold on, there's like so many messages. Here we go. I'm writing it down right here. We have 4 cosine square, and then we have x is equal to 3. I believe this is the question, right? So what do we do? First, you want to isolate the cosine part, right? Whenever you have a trig equation, you want to just work with one trig function, isolate that, and then we talk after that. So divide both sides by 4. Here we have the square though, so we are going to take the square roots to both sides. And then don't forget the plus or minus, cancel this out. Then we get, well, 2 possibilities. Positive version and also a negative version, right? So we have to consider 2 cases. The first case is cosine x equals positive square root of 3. Okay, that's just square root of 3. Over 2, because square root of 4 is equal to 2. And on the other hand, we also have to consider cosine x equals negative square root of 3 over 2. So we have these 2 equations that we have to solve. Then let's see. We also have a condition. We just want from negative pi to 3 pi. Okay, that's interesting. We want this to be on negative pi to 3 pi. We're going to end up with a lot of numbers. Okay. All right, let's see. All right, I'm going to write down the final answer here. So I'm going to put this equation here. Let's consider this one right here in blue. So cosine angle equals equal to positive. Let's do a positive one first. Just kidding, with the over 2. Now, let's go ahead and use the triangle method, because this way you can actually kind of structure the answer instead of just trying to recall what's the value of some angle on the unit circle. Cosine on the unit circle is the x. If you use the triangle method, it's x over r. And this is how I'm going to do it. X is positive square root of 3. R is always positive. I have 2 possibilities. I'm going to draw it right here. X is square root of 3 right here. And then R is 2, so it's right here, like this. That looks like 90 degrees. That's like 45 degrees. No, that's not what I want. It's more like this. Okay, this is 2. 1, 2, square root of 3. Special triangle. If the question is asking you to do without calculator, it's almost always special right triangles. Small side, smallest angle. This right here is 30 degrees, which is pi over 6. So you have to remember the special triangles. So the first answer right here we got is pi over 6. But wait, we could also have gone the other way because we could also have put on the triangle right here. Have a look. Here is still square root of 3, but r is positive 2. R is always positive. I could have put down the hypotenuse right here. Still positive 2. This now is considered to be negative 1. Now we have to be careful. What's this angle here? It depends on how you need to answer it. We want to answer it from negative pi to 3 pi, so we are going to consider a negative angle first. When you go clockwise, this right here is negative pi over 6. In my opinion, when you have an interval, this kind of equation is harder because you have to list them out, a lot of them. All right, so we have 2 answers so far from here, but in fact, we will have more. Okay, we will have more. Let me actually write this down first. So we have pi over 6, and then let's actually put it from the smallest to the biggest. Negative pi over 6 to pi over 6. Yeah, negative pi over 6 and then pi over 6. So 2 answers so far. Now we have to think about it a little bit. Because the interval that they have is from negative pi to 3 pi. And remember, here is 0, here is pi or negative pi, depending on how you look at it. Okay. But it doesn't matter though, because the triangle is on the first and also the fourth quadrant. So this is how we can do it. This is the first negative answer that we have. This is the first positive answer that we have. Now, to get to the next answer, we can rotate 2 pi and then get here again. Why do we do that? Because this is outside of our usual range, right? The range for the x values, I should say the usual domain that we want to look at. So this angle will be pi over 6 plus 2 pi. So I'll put on 2 pi plus pi over 6. And get the common denominator, that's 12, and over 6, which is 13 pi over 6. And you'll see that this is still inside of this. Right? So we'll have 13 pi over 6. Now, let's do the same thing here. Starting right here, and I'm going to rotate 1 time. So I will do 2 pi minus, well, technically it's plus a negative angle. So 2 pi minus pi over 6. Or negative pi over 6 plus 2 pi. Depends on how you want to look at it. That will be 12 pi over 6 minus pi over 6, which is 11 pi over 6. So let me see. Okay, 11 pi over 6. And then 13 pi over 6. If I list them out from the smallest to the biggest. And then can we get to 3 pi? This is 0, this is negative pi, 2 pi, 3 pi, but we don't have triangles here, so we don't really need to worry about that. Okay? Now, I want you to try this one on your own. For this right here, cosine x equals negative square root of 3 over 2. If it's a negative result, put a negative to the top, because when you have cosine, the top value could be negative. R is always positive. Try to draw the triangle. This time that you will see the triangle will be on the second, also the third quadrant. And then this is going to be the reference angle again, but you have to know how to measure the angles, right? Did I forget 5 pi over 6? Let me see. Let me see. No, 5 pi over 6 is from here. It's from here. I'm going to leave that to you guys. I'm just based on this right here. Right, based on this right here, I get this picture and that picture, and then on this interval, we have 4 answers. And then we still have more from here, but I want you guys to try it. All right? Okay, cool. Now, do you guys have all the answers, or yeah, because I want to answer other people's questions too. And then right here, really try it. And if you have any questions, you can leave a comment in the video here, then I can get back to you. Okay, let's see. Okay, why is it 2 pi? Just real quick, because if you have an angle, right here, this is the terminal side. You can rotate 2 pi, which is 360 degrees, and you can get back to the same terminal side. That's the key. Right, that's the key. All right. Let's see. What about negative 2 pi over 3? Negative 2 pi over 3 will be somewhere right here, so it's going to be in this situation. I'm going to leave that to you guys. All right? Negative 5 pi over 6. Again, it's going to be from here. And that's it. You try. You try. You try this one. You will have 4 more answers from here. You have 4 more answers from here, right? All right. Sine of 36 degrees. It might take a while though. I can show you sine of 18 degrees if you would like. Is that fair? And then once you have that, you can use the double angle identity, and you can also figure out the other ones, I think, if that's okay. So let me know. I can do sine of 18 degrees for you. Okay, let me see. If secant A is equal to 5 over 4, verify that. Let me see. Again, I know a lot of you guys are answering this question. It's like right here, right? I'm missing the answers because I want you guys to try this ones, right? All right, secant A is equal to 5 over 4. Verify that expression. I'm not sure if I can do that within a reasonable amount of time, though, so I'm sorry. Let me see if I can just answer some quick questions for now. Okay, is there a basic 101 on this? Do you mean solving trig equations? Maybe in the future, I can just kind of show you guys how to go from scratch. Because the key right here to solve trig equation is that this right here is like the first part. You can use the triangle method, or you can just kind of recall the unit circle. I prefer the triangle method because this way you can kind of structure the answer instead of, you can construct the answer instead of just trying to memorize the answers. Did I take AP Calc BC? Yes, I did. Long time ago, though. Long time ago. Okay. Taylor series, we are not going to cover that in this live stream, though. So, any trig graphing equations with a phase shift and identifying the equation of the transformed function. Let me try if I can give you like a short lesson. But again, if you guys need like more help, make sure you guys check out the QR code here, right? We do offer like a lot more office hours throughout the week, and check them out. They also offer tutors, so they can help you individually, all that stuff. Okay, sine of 18 degrees. If you want that, I'll do that real quick, and then I will do the, because that was the discussion that we had earlier. So sine of 18 degrees. And then R10 of secant. I think you mean the other way around, right? R10 of secant x, that cannot really do much with that. Okay, so sine of 18 degrees. Sine of 18 degrees. Let me show you how to do this one. You start with a triangle. You can also use the formula way, but I prefer the triangle way. The triangle way, much cooler. What you want to do is you construct a triangle. You want to construct an isosceles triangle. Let's say this is 1, this is 1. And what we are going to do is we are going to do 72 here and then 72 here, right? And then we are going to make a cut. Let's see. 180 minus 72 minus 72. That's 6 and then 36, right? So This right here is 36 degrees. Fair? All right, so you construct, this right here is 1, and then you rotate 36 degrees, and you also construct that's 1, and then you have the answer, an isosceles triangle. If I can figure out this, then we're pretty much done. And you see that we have the 36 degrees right here too. Now, check this out. What we are going to do is, we are going to come here, and we are going to do the angle bisection here, like this. Okay. Earlier, I told you guys that we wanted to figure this out, but I don't know what it is. But it's okay. In math, if there's something that you don't know, just call that x. Okay? Now, what we are going to do is, we do the angle bisection right here, right? Angle bisector. So that means this right here is 36 now, and this right here is also 36 now. But guess what? If this is 36, that's just like what we did earlier. 36, 72, this right here will also be 72 degrees, right? So in fact, this side and that side will be equal. This is x, that's also going to be x. Okay, now this is pretty exciting. Have a look. This is 36. That's also 36. Again, isosceles triangle. This is x. This is also going to be x. I'm going to just label this red part x. Okay, that's my hint. Do you guys see how to do this? If you break it down, this is a big one. You have 1, 1, x. Right? You have 1, 1, and x. If you look at the small one here, I'm going to draw this down in red. The small one. The angles are the same, 36, 36, right? 36, 36, and 72, 72, 72, 72. Now, here's x, so we have x and x. What's this side? Remember, the whole thing is equal to 1. This much is x already, so this much is 1 minus x. So 1 minus x. And these two triangles, the best part is what? Similar. Yes. Now, you can do the following. You can do this over that. Set up the proportion, right? This over that is equal to this over that. Depends on how you want to do it. Or you can also do 1 over x is equal to x over that, which is the same thing. Doesn't matter. Now we can just solve for x, right? So multiply, multiply. So we get 1 minus x equals x times x, which is x squared. Move these two things to the other side. X squared plus x minus 1 equal to 0. And then right here, we can use the quadratic formula. X equals negative b, which is 1, plus or minus square root of b squared, which is 1 squared, minus 4ac. A is 1, c is also, well, c is negative 1. I shouldn't say also. All over 2 times a. Have a look. This is negative 1 plus or minus square root. That's 1. Minus minus becomes plus, and then 4. So 1 plus 4 is 5 over 2. X, it's the side of a triangle. It cannot be negative. So we have to get rid of the negative right here. Just get rid of it. Since x has to be positive, we are talking about triangles here, right? Yeah, almost. Yeah. All right, and then let's see. I'm going to put this right here. So I'm going to draw it like, I'm going to draw it one more time. Okay, so here's the triangle. This right here is 1. Let's focus on that. And this right here is negative 1 plus square root of 5 over 2. And then just do an angle bisector again. Now we have a right triangle. And we have a right triangle. And this right here is precisely 18 degrees, because originally that was 36. Do angle bisector. Okay? And then it's just opposite over hypotenuse if you look at this triangle. But this is just half of it though. So you have to divide it by 4. That's negative 1 plus square root of 5 over 4. half of it. So from this picture, you can see sine of 18 degrees equals opposite over hypotenuse. Over 1 doesn't matter, which is just -1 plus square root of 5 over 4. Just like that. And you can also use this to think about how you can do the sine of 36 degrees. Or you can also do the formula way, all right? So that's that. Why does converting your parametric equation to Cartesian? You mean the question that we did earlier when we that was not a parametric trig equation. Though. I'm not sure. Maybe I missed. I may have to just go back to the previous part. Okay. Can you teach multiplying polynomials and trinomials and factoring? Let me answer that real quick. So in pre-calc, this is like, I wouldn't say that the last class that you should really, I wouldn't say, but this is like the class that you really have to start focusing on doing the algebra, because once you get to calculus, you have to learn a lot more new concepts. And of course, you will have to use a lot of algebra. So pre-calculus right here, it's like the key for you to really master your algebra. So can I show you multiplying polynomials? Okay. Let's do this. So if you want to multiply polynomials, here are the formulas that you really, really have to know. So if you have, let's say, a plus b square, this is the formula that you have to know. A squared plus 2ab, and then plus b squared. You have to know this. And then the other one is when you have a minus in between. So you have a squared minus 2ab, and then plus b squared. And then another one that you should know is a minus b times a plus b. This right here gives you a squared minus b squared. So definitely remember these formulas. In pre-calc, I ask my students to remember these two formulas, so when we multiply, it's going to be so much faster. Now, let me show you. So just a first question. Let's say if we have 3x minus 2y and then square. I'm going to use the second formula. The middle right here is a minus. So what we do is we square the first thing. 3x squared, 3 squared is 9, x squared is x squared. Then minus, right here we do 2 times this and that. 2 times 3 is 6, times 2 is 12. And then we have xy. And then lastly, we add this thing squared, so plus 2y squared, which is 2 squared, which is 4. Y squared is y squared, like this. And you should be able to just like look at this and then just write down the answer. Of course, if you are doing this for like the first time or so, I can still, just write down the steps so we can be clear. This right here is the same as 3x squared. How did we get this? It's because we did the 2 times ab. How did we get this? Because we squared the last term. Just like that. All right? So this is how you multiply polynomials, especially with the special products. And let's do another one. Let's say number 2. Let's say if you have 5x squared minus 2y, and then times 5x squared plus 2y. This right here, we're using the third one. So to do this, again, let's try to think about the formula way. I will square the first term. 5 squared is 25. X squared and then square that is x to the fourth power. Minus 2y, and then square that, which is going to be 4y squared. And then we're done. This is it. How do we do it? This right here is because 5x squared squared. This right here is because the second term is 2y squared. And we can only do this when this is the same as that, this is the same as that, but in the middle, the signs are different, right? So really, really useful special product formulas that you should know. And in pre-calc, you will be doing a lot of algebra. And then once you get to calc, not only you have to do the algebra, but you have to learn the new topics. So hope this right here helps. If you know how to multiply different polynomials, I would recommend you to just write them out and do the following. All right. And let me see. Okay, how are you guys doing, by the way? Okay, for the people just coming, thank you guys so much for joining us, though. And this live stream is brought to you by Chegg. Scan the QR code to check out more information, right? Let's see. Oh yeah, so she'll talk about factoring, and I think this is the factoring method I would prefer to show my students. Have a look. Let's do 4x squared minus 5x minus 6. Let's do a factoring with just polynomial, and then let's do one with trig. Have a look. Do the tic-tac-toe method. Just do this. It kind of does require you to guess and check, but I think this is the one that my students feel the most comfortable with. Now, how it works is that you ask yourself, what times 4 give you 4x squared? 2x times 2x, or maybe 4x times x. So we don't know yet. Just give it a try. I'm going to put down 2x times 2x. I don't know if it will work or not. Now, move to the negative 6 and ask yourself, what times 4 give you negative 6? Negative 2 and 3? Okay, let's try it. I don't know. If you put negative 2 here and 3 here, does it work? Have a look. This is how you check it. You do 2x times 3, which is 6x, and then you do this times that, we end up with negative 4x. Together, we end up with 2x. That is not what we want because we're trying to get negative 5x. So this is not the correct combination. So how do we do it though? Let's try again. Right? Let's try 4x and x. Right? And to get negative 6. All right, what do we do? Let me see. What do we do for this one here? Let me see if you... Okay. Negative 6 and 1, it's not going to work. Because if you have to put it down and then you have to kind of check it, and if it doesn't work, just kind of don't give up. Maybe gently cross it out, or maybe use the eraser to erase them. But for this one, it does work. 3 and 2 works. I'm going to put down 3 right. Let's try to do it wrong on purpose. Let me put down 3 here and 2 here, with this being negative. But you'll see, if I do this times this, that will be 12x. If I do this times this, that's negative 2x. Still not correct. We are trying to get negative 5x. But don't give up. Erase, erase. Just try another combination. Let me flip it. Let me try the 2 here and 3 here. I want negative. Have a look. This times this is negative 8x now. This times this is 3x. Together, we do end up with negative 5x. Checks. So this means this factors to this plus that, 4x plus 3. Right, 4x plus 3, this is 3 and negative 2. You go across for the answer, 4x plus 3, and the other one is x minus 2. Done. Just like that. So go ahead and try this. Go ahead and try this. It's really, really useful. And I can also do one with trig 1 with you guys. Yeah, okay. I'm going to erase this. So I can do this as a 2 sine square x and then plus 3 sine x plus 1. Okay, I can still factor it like this. To get 2 sine square, I need 2 sine x times sine x. Yeah? To get 1, just 1 times 1. Now have a look. This times this is 2 sine x. This times this is 1 more sine x. Together, we do get 3 sine x. That's exactly what we want. So, the factoring is 2 sine x plus 1. And then the other one is sine x plus 1. Just like that. All right, so let me see. Okay, so a lot of you guys are participating, which is good. And then let's see. Okay, so I do see blackpenredpen. Can you review polar coordinate shapes like the corduroys? Unfortunately, we only have 9 minutes, so I don't think I can give you like a broad review. But do check the QR code there, and make sure if you need help with trig, there will be other instructors doing other online office hours this week, and we'll be doing this throughout the semester for you guys. I will be back next Monday, same time from 6:45 p.m. to 7:45 p.m. Pacific time. Can you tell me how to do 3D geometry and factors? That's more like calculus 3, right? So yeah, we're trying to do just algebra and also trig here. So yeah, let me see. Can you review changing from one trig function to another using Pythagorean identity? I think I can do that. Let's see. Why don't I do everything for you? In fact, we just need one trig function. So I'm just going to title this, just need sine theta. So let's try everything in terms of sine theta. How's that? Have a look. Because cosine theta, it's equal to, well, remember, the most famous Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. So if I move this to the other side and take the square roots of both sides, we get cosine theta equals 1 minus sine squared theta. Right? We move this to the other side, and then we have to get rid of the square. We just have to take the square root. And technically, you have to be careful if it's positive or negative. Unless you say the angle theta is acute, meaning between 0 and 90 degrees, then everything is positive. But anyways, once you have sine, this is how cosine will be, and then tangent, which is just sine x, well, sine theta over cosine theta. Well, that's just going to be sine theta over this thing, plus or minus square root of 1 minus sine squared theta. And then, of course, we can also do the rest. Cosecant theta, this is just 1 over sine theta. That's it. And then, of course, we can also do secant theta, which is 1 over cosine theta. And we can write it as 1 over that, plus or minus square root of 1 minus sine squared theta. And then cotangent It's just the reciprocal of that, cosine theta over sine theta, which is just the reciprocal of that, plus or minus square root 1 minus sine squared theta over sine theta. So you see, everything is in terms of just sine theta. You really don't need all 6. Does calculus use trigonometry? Yes. You will have to study the derivative of trig functions such as sine, cosine, and then an application for the sine cosine function is when you have a spring, when it goes jumping up and down, right? You will have to use sine cosine to model the motion of the spring. Yeah. All right, so we have 5 more minutes. If you have questions that we didn't have the chance to answer you, don't worry though, we will be back next week, next Monday from 6:45 to 7:45 p.m. Pacific time. I'll be back, and then check out the QR code because there will be other instructors doing live streams throughout the week, and we'll be here for you guys, helping you guys with your studies throughout the semester. I think Thursday we have the calculus live stream, but double check though, click on the live stream or maybe use the link in the description. You can also check out more information. PST means Pacific time. So right now to me it's 7:41 p.m. But we'll be back next week the same time for an hour. Can you show that of all rectangles? It's not that likely for me to be able to show that in like 4 minutes. But the question is, if you have a circle, I'm just going to describe this right here. If you have the same circle, to get the biggest area, that rectangle has to be a square, right? Next time, maybe next time I will explain that. Yeah. Tap the board with your marker to erase it. Later. Okay, let me see. All right, so there's a nice formula. So I'm looking at this question here. If you have like sine and cosine, you combine them, right? So this is also a great question, and I might be able to prove that for you guys next week. But check out the live streams for from other instructors so that you can get your question answered sooner. All right, so f of x equals sine x plus cosine x. You can combine them into r, and then you want just sine of x plus sine angle phi. Okay, the r right here, for this one, it's a square root of, let's say if you have a and b here, it's a squared plus b squared. So in this case, it will be square root of 2. All right, and the angle, if you look up the formula, then this right here, I think it's pi over 4. I think it's pi over 4 for that. So it's square root of 2 and pi over 4. I'm just doing it for my memory because I only have like a minute left. So I'm not exactly sure because I would usually have to work that out. But this will be the amplitude and that will be the phase shift. But I can talk about this in detail and then slowly for you next week. If you come back and ask me the question. Okay, let me see. I cannot do it by proof by just looking at it. That's not proof. Either you use some kind of inequality such as the what's that called? Not Cauchy-Riemann, but AMGM. I don't think AMGM will work for this one. Cauchy inequality maybe, or just do calculus, depends. All right. So we are out of time. Thank you guys so much for coming here today, though. I will see you guys next week. Once again, go check out Chegg and then the links in the description. Thank you guys so much for coming.